Hi, and welcome back to the class. We are going to continue learning about ggplot2 extensions and all the ways that it can improve making graphics programmatically. Because it's a lot easier to do really impressive graphics now. Financial Times does most of their visualizations with ggplot2. This is one that they created using R, and it's a package I think called ggAnimate and Tweener. We're not going to go over that, but it's very easy to find and very fun to use. Let's see, Swiss Info made this all programmatically, and you've got the labels. So with ggRepel and with Annotate and the level of customization you can use, and there's also new packages that help you deal with fonts. Deal with fonts like from Google Fonts or very custom fonts that that your news organization might be using. There's ways to all incorporate that now so that it's easier to export these plots that you've made to something that's workable, and try to keep everything in one system. So, the next thing we're going to talk about is something cool called ridge plots. Let me see if I can find my... Here we go. So, we're going to install a couple of packages. One is ggridges. Install .packages. Ridges, and the second package is called, I don't know why it's not letting me into the script. There we go. Install.packages viridis, and this is kind of some palettes. So let's load those libraries into our system. Library ggridges, library viridis. Okay, so let's look at the temperatures again and visualize it another way. So ggplot temps AES x equals, we're going to use rounded values this time, and we're going to use the month label. And fill is going to be ... x ... This just means all. And this kind of only applies to this specific visualization. So let's move on to geom density ridges, which is from the package ggridges. We're going to give it a scale of 3, relative min height of 0.01 plus scale fill viridis, and I'm going to name the legend that it produces temperature of Fahrenheit, and option equals C plus, and give it labels. Title equals average temperatures since 1895. And I don't need to give it a Y, you'll see why. Because the months are there, right? And it's self-explanatory. Otherwise, X is temperature. And caption is going to be source NOAA. And make the theme minimal, because I don't want anything in the background. Okay, let's run this. Let's run it again. I'm going to cheat and copy and paste my code that I've already written before. Okay. That's pretty cool looking, right? So you see the distribution. So there were more temperatures in January, between around 30 degrees, more temperatures around mid 70s in July and August. So you see that's a pretty interesting way to show distribution in groups instead of how you would normally see this. So that's the way it's kind of stacked together and like gives this really great 3D effect. So let's do this with the ages, actors' ages database that we have. Data frame, ggplot, ages, AES, x equals actress age, y equals actor. So instead of month, we're using actor. Fill equals ... x ... plus geom density ridges gradient. Scale this time is 2. Rel min height equals 0.01 plus scale fill viridis name equals actress age option equals C plus labels. Title is distribution of actress ages for each actor. Y equals nothing, comma, x equals actress age, caption equals source, colon, vulture.com, comma, IMDb, plus theme minimal. Okay. Hey, that's not bad looking. Okay, next thing I want to talk about, heat maps. So you can use this basic geom type from ggplot2 called geom tile. So let's use global land and ocean temperature anomalies with respect to 20th century averages since 1880. This data. So this is what their data looks like annually. So if we did all months, this is what it would look like from them. It's taking a few moments. A lot of moments. Okay, so it's pretty interesting. So there's another way we can visualize this. So let's bring in that data. So anomalies, anom for anomalies, read CSV. Adjust my code from before because it preserves the file structure, and this one I'm going to call it 1880 2018.csv, and I don't need skip, I think. Do I need skip? Yes, I do. So I've got 16,000 rows of data. I need to do that whole thing again where I figure out labels and months, years and months, but fortunately I can just copy and paste my code from before. Repurpose that. And instead I can do, instead of anom, instead of temps, I can replace it with anom by doing find and replace. So you just do edit, find, replace and find. Or press Control F or Command F like I'm doing here. So I will replace temps, and make sure in selection is selected, because it's only going to search within this gray band if I do that. Otherwise, it'll replace it in the entire script. I don't want that. So replace temps with a nom. And replace 14 of them, and this is the new code. And let's see if that worked. And did I get any errors? Ooh. It did not like... Oh, okay. See all those NAs? Something failed. So what happened? A nom. Let's rerun the code again. A nom and year. Okay, because it's looking for date when it was actually year. So I just need to just fix that, and I think this will work now. Yes. Ta-da! Repurposing code. So the code to visualize this as a heat map is ggplot a nom. AES is x equals year. We want the year to be at the bottom. I'm sorry, we want y to be the year. We want it to be up and down because there's so many of them. So it makes sense to be for y equals year. X will be the month label. Fill will be values. Value. Okay, plus, and this is where we use geom tile. And we give it a color of white for the surrounding border. Width is going to be, let's just say 0.9. Height will be 1.1. Theme minimal, let's go ahead and get that in there. It doesn't matter what the order is for these particular layers. Scale, fill, gradient this time. This is where we mess with the colors. Gradient 2. Midpoint equals 0. Because it's going to be a diverging one, right? Because remember that other chart, it started with blue and then went up to red. Midpoint equals 0. Low color is going to be blue. High color is going to be red. And we're going to give it the limits. We're going to make sure there are limits to this between negative 1.3 and 1.3, because that's the variance in the average temperature. Plus, give it some labels. Labs. Title equals global land and ocean temperature anomalies. X equals nothing. Y equals nothing. Caption is source NOAA. Anything else? I'm gonna move the legend to the top. So I do scale X. Actually, yeah. Scale X. So one thing is we're going to do. Well, I want to move the labels to the top. So that means theme legend dot position equals top. And I'm going to move the labels from the x-axis at the bottom so that it's at the top, because it's going to be a long data frame and it makes more sense for this to be at the top. So like I said, it's just about styling at this point. So let's run all this. Fingers crossed it works. Didn't like color. What is wrong with color? Oh, color is color. No, it needs to be white. I don't know why I did that. Ooh. Okay. So the thing is, these fonts are really huge. So what if I saved it? GG save heatmap.png height equals, let's give it what makes sense for the height? 40. Width equals 10, and units equals cm. Let's see how that looks. Heat map. Ah. That's pretty interesting, right? Now I might need to shrink this a bit and change the colors. But you can see it's getting definitely warmer in the more recent years. You can see it kind of fluctuate. Oh, this should have been up top. Well, that's weird. Why didn't it go up top? Oh, you know why? Because it should be. I've repeated myself. It's scale, x, discrete, and then position equals top. So let's run all that again. GG save. Okay, that makes more sense, right? You see now the months label are up here. It's nice. You know what? We should probably redo this so it makes, it's in chronological order. So let's go back to anom and reorder the data there. Anom is going to be taking anom and mutating the year based on, remember, fct underscore rev. So reverse it, you can just do fct reverse, whereas before it's factor reorder. But for this one, it's very much similar to this factor of year. So I got some nested stuff going on. Factor reverse and factor of year. Okay, that should save. And now when I run all this code again, what happens when I open up ggmap? It's flipped. Ta-da! Look at that, one quick adjustment, and you don't have to restart your code over again. Very cool. Next, I'm going to talk about Mr. Rogers. So, someone sat down and identified every single color of sweater that Mr. Rogers wore during his time on his show. And someone went, and so I guess his name is Owen Phillips. He's scraped it with R. And the code to do so is linked here. It's not that long to do, to come up with yourself. But I'm going to quickly show you the code behind it. So that data is in the folder called Mr. Rogers. So Rogers read CSV. Repurpose my code. Data, and then replace this with Mr. Rogers. Get rid of this skip. Replace it with an end parenthesis. Rogers, and we have a data frame of episode number, color, the hex code for the color of the sweater, and the year, and I suppose how often he wore it. Yeah. So we're running out of time, so I'm just going to copy and paste the code over. Actually, I'll copy and paste the next code, but for this one, I'll just show you. First, I'm going to just use his code. It's na.omit. We get rid of all the NAs in the Rogers data frame. And then pipe that into ggplot. And where AES is going to be, because we don't need the data frame because it's being piped in. So x equals episode numbers plus, and we're going to do geom bars because we want to visualize all the sweaters. Geom bar, singular. AES fill equals factor color codes. Oh, and let's actually extract all the colors by doing cn unique Rogers color codes. So now we've got cn, we've got 17 different colors. And I think there's something wrong with the data frame because I feel like there's more colors, but when you go through this, it might be fixed by then. But for now, we have 17. So color codes plus scale, fill, manual, and values are being passed from that array that we created, cn. Plus, theme minimal, and then give it some labels. I'm going to copy and paste that over. Actually, I'm going to copy and paste the rest of it over. So I'll just walk you through it. We've got labels here. Fill, nothing. So there's no legend. X's labels, nothing. We give it a title, subtitle, caption, blank, blank, blank. Guides, we want to fill with the legend. Scale, X discrete, we want to limit it between 1466 and 1761. Right, for episodes. Because that's just the number. Labels is going to be 1979 to 2001. Give it a theme, so we get rid of all those grids in the background, and we're going to get rid of the legend, and the Y limit is going to be 1, 0 to 1. So then we get something like this. Alright, we now have a history of Mr. Rogers' sweaters, at least based on this data frame, which might need some cleaning up. It's a little bit old. So last one I want to show you, and I'm just going to copy and paste it, honestly, is this visualization by John Muskins of the Washington Post, colleague of mine. He created this in D3. And this is all the students that have experienced gun violence at school since Columbine. And this is counting up all the number of students there are per school, per shooting, over time. And you see, it's a very innovative way to show the impact. And it's really smart to do it this way because there's going to be more. And whereas in other data visualizations, if it was a flat line, it would get pretty crowded and you'd have to keep scrolling left and right. But this one, the circles will just decrease in size, and you can still see the scope of everything since 2000. Right, so this is a very innovative way and a pretty cool way to do it. But before he visualized this in D3, he played around with it in R to visualize, and he used a couple of packages. Scales is one new one, GG Labeler and GGB Swarm. So I'll show you that. Install .packages, GGB Swarm, install .packages, and this is going to be actually from GitHub because it's not on Crayon, or it might be, but the latest version is the one you want. So DevTools install _GitHub, GG Labeler, packages, scales, install .packages, redar. I think we've used redar already, but okay, let's see if that worked. Yeah, great. Okay, so the first line, bring over from the walkthrough, please. It's pretty much from the GitHub page, the CSV file, and you can download it that way. So now data is in here. We've got all the schools, we've got all the shootings, we've got students, population. Actually, let me bring that in again with the full data set. This is fine. So what this did is it kind of adds a little bit more data for columns. You can add some extra stuff to read CSV if you want. Okay, so the next thing he did, this is his code that I'm bringing over, is he created a new theme specifically for this, where he took theme minimal and he got rid of even more stuff. So the axis text, axis ticks, the lines, and the panel grid. It's like, so he combined that into this thing called theme. Okay, and you can add that to the end of your ggplot list of layers, and it will bring that code in. Fine. So I'm going to copy and paste this last bit of code. We're running out of time. So I'll tell you what this is. So he brings in the data frame data with all the school stuff. AES is, yes, data, 0. Size is enrollment, and this doesn't meet. And ggBSwarm is the function. And method this is one of the things from GBSwarm. Dodge with group on X, scale size area, scale X date, and continuous. And he used this thing called chord polar, and he changed the direction, and he added that theme. So let's run this, and it looks like that. Pretty interesting, right? So this is how he kind of played around with before he got to see like how this might look visually before he transitioned this to ggplot. I'm sorry, to D3. So I think if I do gg save, you know what? Never mind. So if you save this, and so he saved this as a PDF, and it saved it into a bigger format so he can see like the sizes, because you can see it shrunk. But when it's spread out in the PDF, he could play around with that even more. So congrats on making it through the chapter of visualizing data with ggplot. I hope you've learned a lot. I've thrown a lot at you. There's so much more that people are coming up with. I'll include links to it, but I just hope you get to just see and envision all the possibilities that you can do with data now, and ways to visualize it. So thanks for making it this far. In the next section, we're going to go into spatial analysis, visualizing maps. It's also, you're going to have a good time. All right, see you then.